Welcome to Algeomelis Prep Academy. The lesson for today is related rates between moving vehicles. For our first example problem, two boats are traveling on sailing routes such that the two boats are on a collision course at a right angle. Boat A is 300 miles away from the collision point and is traveling at 30 miles per hour. At this same instance, the distance between boat A and boat B is 500 miles apart. The distance between the boats is decreasing at 50 miles per hour. Our task is to find the speed of boat B as it approaches the collision point. Our first step will be to draw a diagram of the situation. Our diagram will look like a right triangle with sides A, B, and D, with A being directly to the left of the collision point and B being directly below the collision point. Side D represents the distance between the two boats. The next step is to list everything that we are given in the problem and the thing that we are solving for. This will include the rates of change and the length of certain sides that we know. The ADT will be 30 miles per hour and the DDT will be equal to negative 50 miles per hour. The rate of change of side B is unknown, but we are trying to solve it when D is equal to 500 miles and when A is equal to 300 miles. To solve for the rate of change of B, we need to know B itself at that instance that we are measuring the rate of change. To do this, we can use the Pythagorean theorem by using a squared plus b squared equals d squared and simply plugging in a and d and solving for b. When taking the square root, we usually put our plus or minus right before it, but since this is a distance we are measuring, it cannot be negative, so it must be positive. And at the end of this, b comes out to 400 miles. Next, we need to find an equation that contains our unknown inside of it. Our unknown is dB dt. So we can implicitly differentiate our Pythagorean equation from earlier, a squared plus b squared equals d squared, to get the new equation 2a times dA dt plus 2b times dB dt is equal to 2d times dd dt. This new equation now contains our unknown variable, and using what we already know, we can begin to solve for it. By plugging everything in and then isolating dB dt, we come out to an answer of negative 85 miles per hour. But the question was asking what the speed of boat B is, which will be the absolute value of the rate of change. So the true answer is 85 miles per hour. For our final example, an airplane flying due north at 270 miles per hour passes over a house at 2 p.m. Another plane flying due east flies over the same house at 350 miles per hour at 2:45 p.m. How much is the distance between the planes increasing at 3 p.m.? We will begin this problem by drawing a diagram and listing our givens. Our givens are dx dt equals 350 miles per hour and dy dt equals 270 miles per hour. Our first diagram has a plane directly over the house at 2 p.m. and a plane to the left of the house at that same time. Our second diagram shows the situation an hour later, where the first plane is now directly above the house and the second plane is directly to the right of the house. The distance between the first plane and the house is y, and the distance between the second plane and the house is x. The distance between the two planes is represented by side z. These three sides come together to create a right triangle. We will also solve for x and y in this step by using the time and the rate of change to get x and y.
Plane 2 has been traveling since 2:45 p.m. to 3 p.m., which is 15 minutes. This is 1/4 of an hour, so multiplying this by the rate 350 miles per hour gives the x distance of 87.5 miles. Plane 1 has been traveling since 2 p.m. to 3 p.m., which is an hour. Multiplying this by the rate of 270 miles per hour gives the y distance of 270 miles.
To find the rate of change between the two planes, we will once again need to find the distance between the two planes at that same time. We can use the Pythagorean theorem by using x squared plus y squared equals z squared. Next, we can plug in x and y and take the square root of both sides to find z. This will be a positive answer and not a negative one because the distance cannot be negative. Next, we need to find an equation that contains dz dt inside of it. We'll implicitly differentiate our Pythagorean theorem equation from the last step to get 2x dx dt plus 2y dy dt equals 2z dz dt. This new equation now has dz dt inside of it, and we know all of the 5 other unknowns, which means that we can now plug all of our values in and begin to isolate dz dt. By doing this, we can get the exact value of dz dt and estimate its value to 3 places past the decimal, which gets us 364.75 miles per hour. This is the rate at which the distance between the airplanes is increasing at that time. Thank you for watching Algeomelis Prep Academy. Don't forget to like and subscribe if you enjoyed the video.